There are several types of rigid body motions, and each of these different motions has kind of a different plan of attack for them. The simplest kinds of motion are rectilinear and curvilinear translation, and in these two types of motion, each point on your object has the same velocity. So rectilinear translation would mean taking an object and we can have it move just straight in the X direction or straight in the Y direction, or just any kind of straight line motion where, because there's no rotation of the object happening, each point, each corner has the same velocity as every other corner. So that would be rectilinear. Linear would mean just straight line motion. And if you know what one piece of it is doing, you know what every piece of it is doing. Curvilinear translation. Okay, so curvilinear means we're following some curved path instead of a straight line path, but the object itself is still not rotating. So one corner is still going to have the same velocity as any other corner. So if you know what one piece of it is doing, you know what all of the different pieces are doing. Okay, next up is rotation about a fixed axis. For rotation about a fixed axis, different corners are going to have different velocities, but everything you know about rotational motion is going to apply. So V is equal to R omega. If you just know how far away you are from that axis of rotation, you can find the velocity at the different corners. So the velocity at something far away from the axis will have a larger velocity than something close together. But having a fixed axis very much simplifies this in that you can kind of have everything rotating around that single point. So that is rotation about a fixed axis. General plane motion. So this is still happening in a two-dimensional plane, but general motion means we do not have a fixed axis of rotation, and we do not have just straight translational or straight rotational motion. So if you look at how just the arm of this double pendulum is moving, that would be general plane motion, where there's rotation going on and translation going on. So a little bit of craziness, but we're still confining the motion to a two-dimensional plane. Next up, motion about a fixed point. So not rotation about an axis, we're just talking about a single point now instead of an entire axis. And our motion is going to be three-dimensional, so we're not confined to a single plane anymore. So this would be something akin to a gyroscope, which we'll talk a little bit about how gyroscopes work in the future as well. The final kind of motion we have is general motion that involves both three-dimensional translational motion and three-dimensional rotational motion. And this is kind of the worst case scenario. There is no fixed axis of rotation, no fixed point of rotation. You don't even have a linear line. So this could be moving in a curve, so just extra chaotic motion in all three dimensions would be the last case. Okay, so just a quick recap. Kinematics of rigid bodies. Again, this is going to be kinematics, and the next chapter will be kinetics. So kinematics is, we're worried about the motion without reference to the forces that create the motion. So purely like the constant acceleration problems or x equals x naught plus vt sort of a deal. No forces yet, we'll do that next. So this is chapter 11 again, only it's chapter 11 with two- and three-dimensional objects. The different types of motion we will have in this are translational motion, and translation can be broken into rectilinear translation, in which everything is traveling in a straight line and all of the particles on the object have the same simultaneous velocities and accelerations. Curvilinear translation where we're not traveling in a straight line anymore, but the object itself is not rotating. So because it's not rotating, each particle has, again, the same simultaneous velocities and acceleration. So if you know the velocity of one piece of it, you also know the velocity of every particle in that object. The next classification is rotation about a fixed axis. So in this case, if you simply know the distance of each particle from that axis of rotation, you're going to use relationships such as v equals r omega, or acceleration equals r alpha. So if you have information about how fast it's rotating about that axis, you can find the velocities of all of the different points with respect to that axis. We also have general plane motion. In plane meaning confined to a two-dimensional surface. And imagine this ruler or post that's falling. So it's both rotating and has translational motion. So the center of mass has fallen, and it is also at a different orientation by the end of it. So general plane motion in 2D is going to be a combination of translational motion and rotational motion. We then have motion about a fixed point. So this is the gyroscopic motion. And don't mix up motion around an axis with motion around a single point. So we're getting into three-dimensional motions with this type of scenario. And last but not least is the general motion, which is three-dimensional translational and rotational motion. So this is the worst case scenario where we have no fixed point, no fixed axis, and it is both translating and rotating in all three dimensions.